To evaluate the integral 0 to infinity x log x over 1 plus x power 2 whole power 2 dx, you might think that substituting x as tan theta is a brilliant move. And it's true, the substitution can work. However, as we will see, it's not the most efficient way to simplify this integral. Let's go ahead and try the substitution. X equal to tan theta, then if we do derivative of x, that is derivative of tan theta, which is secant square theta d theta. At the denominator we have 1 plus x power 2, that means 1 plus tan square theta, which is secant square theta, isn't it? So let's substitute here. Integral, so x we consider as tan theta, so let's take tan theta, and log tan theta over 1 plus x power 2, which is secant square theta whole power 2 times dx is nothing but secant square theta d theta. Here 1 secant square theta and here secant square theta gets cancelled, so you are left only with secant square theta. So let's remove this. Then integral tan theta we can write this as sin theta over cos theta, and times this secant square theta we can write it as 1 over cos square theta, isn't it? So 1 over cos square theta log tan theta d theta. Here 1 cos square and here 1 cos theta gets cancelled, so here left only cos theta at the numerator, isn't it? So now we have sin theta cos theta log tan theta d theta. If you multiply and divide it by 2 by 2, then you will get 1 by 2 times 2 sin theta cos theta. 2 sin theta cos theta, the formula is sin 2 theta. After a few more steps, we got this, which is 1 over 2 integral sin 2 theta log tan theta d theta, isn't it? So if you take lower limit x as 0, so that is we consider x as tan theta, that is equal to tan 0. So tan 0, the value is 0 only, so the lower limit turns into 0. The upper limit x equal to infinity, that you have to take tan infinity, which is pi by 2. So the upper limit turn into pi by 2. So 0 to pi by 2. So let's consider this as equation 1. To evaluate this equation 1, we have to use integration by parts, isn't it? So again we have to choose u as log tan theta and dv as integral sin 2 theta d theta. You have to consider u as log tan theta and dv as 1 over 2 sin 2 theta d theta. And you have to continue this. As you can see, first you are considering x as tan theta, and after doing a few more simplification, again we got this lengthy function. Again you have to consider u as log tan theta. So this process is quite lengthy and difficult. So what's the better way? The correct move is substitute x as 1 over t. So this we can write it as x equal to t power minus 1. This might seem like a simple substitution, but it's actually a clever technique that simplifies the integration quickly. So if we do derivative of x, so the formula is n times x power n minus 1. So our n is minus 1 times t power n minus 1, that is minus 1 minus 1. Our n is minus 1 minus 1, which gives minus 2. So this we can write it as minus 1 over t power 2. So our dx is minus 1 over t power 2 dt. Integral we consider as I. So then I equal to integral x we consider as 1 over t. Let's take 1 over t log 1 over t. Here 1 over t we can write it as t power minus 1 over 1 plus x power 2, that means 1 over t whole power 2. We can write this as 1 over t power 2. Still we have power 2. So let's take power 2. Then dx is minus 1 over t power 2 dt. Now observe the limits. We have 0 as lower limit. So we consider x as 1 over t. Let's take x as 0. That means 1 over t is 0. That is t equal to 1 over 0, which is infinity. So the lower limit turns into infinity. Now let's take the upper limit. X, take it as infinity. So then 1 over t is infinity. Then t equal to 1 over infinity, which is 0. So the upper limit turns into 0. Observe the denominator. We have 1 plus 1 over t power 2 whole power 2. If you take LCM here, we'll get t power 2 plus 1 over t power 2 whole power 2. Isn't it? This we can write as t power 2 plus 1 whole power 2 over t power 2 whole power 2. Denominator 1 plus 1 over t power 2 whole power 2, we can write it as t power 2 plus 1 whole power 2 over t power 2 whole power 2, isn't it? And numerator we have 1 over t. So let's write it here 1 over t, and this it becomes t power 4. And it goes into numerator, isn't it? So let's write it here t power 4. At numerator we have t power 4. At denominator we have t power 1 times t power 2. After cancelling all, we get only t at the numerator. After simplifying, then we will get integral infinity to 0. We have minus. Let's take it for front minus. We have t log t power minus 1 over this. We can write it as 1 plus t power 2 whole power 2 dt, isn't it? This we got. This is a negative function. To make it positive, we can change the limits, lower to upper, upper to lower, isn't it? Then the function turns into positive. This is our definite integration property. So use that property here. Let's make it this function as positive, changing the integrals 0 to infinity. And observe this logarithm term. We have log t power minus 1. It is in the form of log of a power m. The formula is m times log a, isn't it? So we can write this as minus 1 times log t minus times log t t log t over 1 plus t power 2 whole power 2 dt. Do you observe this? It is same as our given function x log x over 1 plus x power 2 whole power 2 dx. So here it is in terms of t, and here it is in terms of x. So according to the definite property 1, we can replace x with the t. If you replace x as t, the expression function remain the same. So using that property, according to that property, I'm going to take this t as x. So if you take that t as x also, the function would be same. So which is x log x over 1 plus x raised to the power of 2 whole raised to the power of 2 dx. So it is same as like I. So that's why instead of this, I'm going to write minus I. And here left hand side we have I. So I equal to minus I. So this we can write this as I plus I, that is equal to 0. Then 2I equal to 0. Then I equal to 0. That means this integral 0 to infinity x log x over 1 plus x power 2 whole power 2 dx, the value is 0. So within only 2 steps, we solve this integration. This clever substitution saves from the lengthy process and provides a much simpler solution. So that's why whenever you see this integration problem, instead of taking x as tan theta, you have to introduce x as 1 over t. That's it. I hope this video is helpful for you. If you found this video as helpful, please consider subscribing my channel. Thank you for watching.